Today we're at the Kennedy Space Center where we are doing some really amazing things. In just a few days, we're going to launch the Boeing Starliner. With the completion of this test, we will be one step closer to launching American astronauts on American rockets from American soil for the first time since the retirement of the space shuttles in 2011.
All right, well, good morning and welcome to the Kennedy Space Center, America's premier multi-user spaceport. It is absolutely great here today, getting ready for Boeing's commercial crew launch of the Starliner. I can't say enough good things about what we're doing here at KSC. I think it's pretty amazing when you look out at all that's going on. And today we've got our NASA Administrator Jim Bridenstine and this awesome Boeing commercial crew cadre.
I remember it wasn't too long ago it was announced that the space shuttles were going to retire. The Constellation program was going to be canceled. And of course, here at the Space Coast in Central Florida, there was a lot of concerns and a lot of families were hurting. But Bob, because of your leadership and the great things you've done, you've transformed this facility into a multi-user spaceport where we've got commercial activities happening side by side with government activities. These are very exciting times for the Kennedy Space Center, very exciting times for Central Florida.
How are you, sir?
Hey, good to see you.
Good to see you. Thanks for being here.
Katie?
Good to see you again, sir.
Good to see you always. How are you?
Good.
Excellent.
Welcome.
Hey, Jim, how are you doing?
Great to see you.
Awesome, thank you.
Welcome to the Starliner High Bay where the spaceships are born.
It's pretty amazing, isn't it?
Yeah.
Tell me about these. What are we looking at here?
Let me start over here. That is a spacecraft that just flew our pad abort test.
Yep. Yeah.
And with that, we proved that the guidance system talks to the thrusters and the come home system all works great. So
Yep.
we're confident to go press onto orbit.
So that's that vehicle.
That's the one.
That's the very one.
And we have a little tradition. On a spacecraft going to space, you can't do anything too funky. This one came home and the team has signed it.
Oh, wow.
They've said, that's our work.
Okay.
And I'm wondering if you would do us the honor of representing the NASA teammates.
I would love to.
Come on up and sign her.
All right,
Would
let's
you?
do it.
This was a test vehicle. Can I show you the first one to carry people?
Absolutely.
Let's go talk to Chris Ferguson. He's going to fly in her.
Okay. Hey, Chris.
How are you doing?
Good to see you.
It's good to see you.
Absolutely.
So this is number 2 of 3. These capsules are mostly autonomous,
Okay.
which means they sort of launch and they're able to find the International Space Station and dock with it with little or no assistance from an astronaut. However, there is the system in place in case the astronaut needs to take over, where they can guide it and manually dock it if need be.
Okay.
With an autonomous vehicle, we are largely a monitor, right, to make sure things go off as they're supposed to, and then an action, if it was intended, is in fact completed. And the way we manage that is we actually watch the script execute right on the screen.
So, Chris, you personally are going to fly on this vehicle, and maybe multiple times into the future. I mean, who knows? And this is historic. You as a Boeing astronaut are really blazing a trail.
I think that this is the beginning of something that we'll see a lot more of. You know, early on, we had military pilots work hand in hand with the government test pilots to develop airplanes, and I think what you're seeing now is just an extension of that.
As a nation, as an agency, we need to see a lot more commercial astronauts and a lot more commercial activities in space. Ultimately, because that's how the future is going to be. We need to see lines of effort that include advanced manufacturing and industrialized biomedicine in space, with a lot of the capital coming not from just the American taxpayer, but capital coming from private industry, improving the lives of humans here on Earth. And that's what the commercial industry is all about, and that's why we need commercial astronauts. So the vehicle that we're in right now is called the Astro Van. Tell me what does that mean? What is that all about?
This is the second generation of Astrovan, and this is what we'll use to take the NASA astronauts from crew quarters, which is in sort of the industrial office area, about 7 miles or so out to the launch pad.
Okay.
So it takes about 15 minutes to get there. And so, we always used to say it's one of the longest and loneliest rides you'll ever take in an Airstream trailer. But and it was interesting, along the way you drop off various people, and then you realize the only people left on the van when you got to the launch pad was the crew. So we always used to joke that the smart ones got off.
So Tori, we're at Slick 41. Tell us, what is Slick 41 and what do we have behind us?
So Slick 41 is the home of the mighty Atlas rocket. This will be our 81st launch of this rocket. So this giant manifold here is part of our acoustic suppression system. It's going to spray water, unmistakable when you see the launch go off. You'll see all that water. Most people think that's for fire, but really the interesting thing is it's not. It's for sound. Because when the rocket clears that launch pad, the sound coming out of those rocket motors and rocket engine is so loud, if it reflected back off this pad, it would damage the spacecraft. In fact, if you could stand here and somehow survive the fire, the sound alone would kill you.
Oh, wow.
And so all of that water present on the pad absorbs the acoustic energy and protects our payload.
Well, make sure that water works. Can you do that?
I will absolutely double check it. So those big white cylinders you see on the side are solid rocket motors. They give us extra impulse coming up off the pad. That's a lot of propellant, and it's going to generate each one of those almost 400,000 pounds of thrust. In the center, that big tube in the middle, the bronze colored one, that's our main propellant tank for the center core. We can step up here. So that's the real McCoy, all 109,000 pounds of solid propellant. And that's a heck of a view.
It's pretty awesome.
Yeah, 190 feet straight up.
Mr.
Nicole?
Administrator,
Mike.
welcome to the 12th floor.
Thank you. It's good to be here.
Sir, good to see you.
Nicole, good to see you guys. I'll tell you, it looks tall from the ground, but when you're up here, it feels a lot taller than it
feels
looks from the
tall.
ground, especially with these winds. Well, I'll tell you, you can really feel the wind when you're up here, and I can imagine maybe tomorrow the wind won't be so high, but certainly I can imagine when you go across this. I know it's an access arm, but it looks like a very narrow catwalk if you ask me.
Well, we'll be coming out here in our spacesuits.
Yeah.
And we're going to be, even though we're steely, aviators, we're still going to have a lot of emotions. This is our last moments on planet Earth before we go launch into space.
Yeah.
And the winds are actually a blessing, because in space station, there's no wind, right?
Right.
And so everything's the same all the time. And then here we're getting like a kiss from Mother Earth as we get ready. So we walk across here, we walk down this access arm, we can feel the positive energy from all the people that worked so hard on this mission, and then we go in and close those doors. We're just feeling proud, we're feeling a little bit scared, a little bit anxious, but we're like totally trusting our training, we're totally trusting Team NASA, Team Boeing, and the United Launch Alliance.
So of course you can see your Starliner sitting there on top, and that's where Spanky and I and Fergie, when we climb in through the crew access arm right into the side hatch, we go into Starliner. On the top of that is the IVA hatch, and that's what's going to dock with the International Space Station. Beneath Starliner, you can see the service module. That's where it has a lot of our life support system, our prop, the engines while we're orbiting and maneuvering in space. And then below that, you can see this amazing Atlas fight rocket.
Well, I'll tell you, what you guys are doing is going to inspire the nation, but not just our nation, also people all around the world that are going to be watching this. So thank you so much for what you do.
Thanks for the opportunity.
Thank you.
Thank you, sir. We'll do well.
All right.
Sonny, what are we doing here?
So we're at Spacecraft Launch Complex 41, standing in the shadow of the Atlas V with the Starliner on top, with the crew access arm connected to it, ready actually for people to eventually get on board. We got Rosie, the mannequin inside that is instrumented, and so we're going to get some data to see what our ride's going to be like when Josh and I actually get to fly on this thing, probably at the end of next year.
Great. And Josh, what's your role in this?
To not mess anything up is the goal today. This is the capsule that Sonny and I are going to have a chance to fly in, along with 2 others. And so we're following the whole process from beginning to end. From launch tomorrow morning to docking the next day and to landing a week and a half later. For me, it's just a situation where I find myself pinching myself. It's just, it's incredible to see this happen. We're living science fiction. It's really happening right here.
We've actually done a lot of engineering work with the Boeing team to work on the software, so when the humans are interacting, they've got that situational awareness of all the automation that's processing in the spacecraft and how we would recognize if there was an issue or a problem and how we would interact with it.
We're looking at where our future is. We have a $400 billion space economy. What you're doing is leading the way for that space economy, lowering the cost of space travel and providing more access to more humans on Earth to get to space. It's about expanding the human condition by finding new knowledge. And I'm just so proud to be with you, but that's why we're here. So I thank you for what you're doing.
This is a new era in human spaceflight. And there's a number of reasons why this day is so important. We are on the cusp of launching once again American astronauts on American rockets from American soil for the first time since 2011, the retirement of the space shuttle. So this is a big day.
How many of you have seen a rocket launch before? Can I get a show of hands? Oh man, you got, okay, how many have not? Let me put it that way. This is the group I want to talk to, all right? Anytime a rocket ship leaves planet Earth, it is an experience. I don't care what's on it. And you see it, you feel it, you experience it, it's emotional.
Welcome this morning to NASA's Kennedy Space Center in Florida.
Starliner is nearly ready for our uncrewed orbital flight test. You can see it over our shoulders, lit up on the launch pad. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and liftoff. The rise of Starliner and a new era in human spaceflight.
And Atlas 5 is now traveling at over 5 times the speed of sound. And we have BECO booster engine cutoff standing by for stage separation. And we have good indication of stage separation.
We had a great launch this morning, and the Starliner is now in orbit around the Earth, and that's because of the great work that you here at Boeing have done with your partners at NASA. That's important, and it needs to be recognized. And I know, I see that look around, I see a lot of people that are concerned and worried about the fact that the insertion burn did not go according to plan. And it's of course a concern to me as well. It's a concern to all of us. But here's why we test. Because we're going to learn things. And from what we learn, we're going to make changes and we will move forward. That's what we do. And so this is a good day. It's a good day.
We train extensively for this type of contingency. And had we been on board, there could have been actions that we could have taken. This vehicle is a new level of automation that we've never seen before. And so what we're really doing is we're testing that automation, and that's why you have test pilots on board, especially for these early missions. That's our job, that's what we're trained to do. We are looking forward to flying on Starliner. We don't have any safety concerns. Everything on the ascent, all the systems that would keep us safe have functioned properly on the launch and currently on the vehicle. We're looking forward to all the test data, and we're looking forward to landing at White Sands.
Good morning from Starliner Mission Control in Houston. It's December 22nd, 2019, and we think this will be a day to remember.
We have chosen the longest night of the year to bring Starliner home. Happy winter solstice to everyone. Starliner flight control teams have been working around the clock to get Starliner set up for a safe landing, and today is the day. The entire team here in the room is quietly watching, making sure all the systems continue to look good.
And we see three main chutes. We see the red, white, and blue as Starliner descends. Base heat shield has jettisoned. That is the base heat shield falling away as planned. Airbags are inflating.
And that is the last of the milestones, so now all that's left is for Starliner to float down to the surface of the desert.
And Starliner touches down in the desert in New Mexico. An historic landing in White Sands, New Mexico concludes the first flight test of Boeing Starliner spacecraft. The first time an American-made, human-rated capsule has landed on land.
Congratulations, Starliner.
Congratulations, indeed.
This is my first spacecraft landing. It was incredible in sea. We're so excited for the Boeing and NASA team and the recovery forces today. Just did an incredible job.
Yeah, we got a lot of data on the launch, the orbital portion of the flight.
Being able to just watch the entire sequence from the ground on down was just fantastic. Really clean landing.
We had a beautiful, amazing team all out here ready to support. Everybody was pumped, everybody was cheering. It was spectacular. I mean, she's back, she's home.
We are really, first and foremost, pleased with how this team came together. Flying a different trajectory, different aero shape, you can only test that at scale. That went terrific. Return is something that you can't really test. You got to put your heat shield on and go through the heat regime. Today it couldn't really have gone any better. The ground crews, Chris, Nicole, Mike, they're telling us there's hardly any charring, perfectly level on our airbags, and that bodes really well for reusability. From an overall perspective, we are just as pleased as we could be with the design.
I would say the team did just a tremendous job. What you find sometimes is when you execute a flight differently than planned and a mission test flight differently than planned, that team comes together in a unique way. And the NASA team, the NASA engineers, the flight control team, the Boeing team working side by side to solve problems in real time, to come up with innovative solutions, to keep decisions ahead of them, and then to end up like today where we had a successful deorbit burn and entry and landing. If I look back at this year from a commercial crew perspective as a program, you know, we've had a tremendous year. With the holidays in front of them, they just did a tremendous job, and so my hat's off to them.
So number one, congratulations. I know the last 48 hours have not been easy. So when you think about a mission like this or a test flight like this, when we think about this, launch, of course, is a big challenge that has to be overcome. That happened. Flying the spacecraft and making sure that the systems work, that happened. Entry, descent, and landing happened. We're going to get a lot of data, we're going to get a lot of information, but a lot of really, really good things happened on this test flight. It is also true that when things go wrong, that's when you learn how the teams work. I'm telling you, that was a thing of beauty. And everything that I've been told from the people that were in the room, decisions were made quickly, things happened that were not planned, and because of that, this test flight was actually very successful in so many ways. So thank you for all of your service to the country and all of your service to NASA. So thank you.